Well, hey there, kiddos. I hope you have enjoyed your nice long weekend. I know that I have. We are going to start solving systems of equations today. Everything we've done till now has just been about setting up the system and recognizing a system and determining if something was a solution or not. Now we're actually going to find the solution on our own. There are three methods we'll use to do this. One of them is substitution, the one we're going to talk about today. Then there's elimination, and then there is graphing. All three can be used at any point in time, but there is always a best place to use one over the other. Substitution is better used in some places than elimination is, and we'll talk about that. Substitution is exactly what it sounds like. We're going to be doing a substitution. Your goal whenever solving a system of equations is to get down to where you have an equation with only one variable in it, because that we know how to solve, and then using that to find the other. So substitution is best used when one variable is already isolated, so it's by itself, or it can be easily isolated. And we'll do examples of both today. Okay, so substitution is best used whenever a variable is already by itself, or you can easily get that variable by itself. But I use substitution only whenever I have a variable all by itself, and it's very quick and simple. So let's start some examples. Here's your first example. You see you have two equations and there's two variables. So I have y equals 2x plus 5, and then I have 3x minus y equals 10. Well, in this top equation, y is isolated. It is all by itself. And I know that y equals 2x plus 5. So I can take that 2x plus 5 and substitute it in for y in the bottom equation, because that's what y equals. So I'm just going to replace y with 2x plus 5 in this equation. So I'm going to do 3x minus, and in parentheses I'm going to put this because that minus sign changes things. So I have minus 2x plus 5 equals 10. All I did was replace y with that. Now I'm going to distribute this negative through the parentheses, so I make parentheses go away. So I have 3x minus 2x, and then this negative and that positive make a minus 5 equals 10. Combine our like terms. 3x minus 2x gives me 1x minus 5 equals 10. And so now you'll see I've simplified this to where I have an equation that only has one variable that's very easy to solve. If I add 5 to both sides, you get that x equals 15. Now you're only halfway done, because when you solve a system of equations, you have to find out both x and y, because the solution to this is where these two lines intersect, and so it's a point on the graph, and every point on every graph has two coordinates, an x and a y. So now I got to find y. Since I know that x equals 15, I get to substitute again. You can plug this in for x in either of these two equations, but I'm going to use the top one, because the top one, y is isolated, and so I just plug it in. It's straightforward. I don't have to do anything extra. If I plug 15 into the bottom equation for x, it will take more work. So we're going to plug it into the top one where y is isolated. So I have y equals 2 times 15, because x equals 15, plus 5. Now it's just a matter of doing the calculations. That equals 30 plus 5. And so y equals 35. Since the solution to this is a point on a graph, it's where these two lines cross, I must write my solution as an ordered pair. This is my solution to that system of equations. Okay, x then y, it's an ordered pair. Now you see down here it asks you to find x plus y. Sometimes you might be asked to do something with that. Well, since I know x and y, I just plug them in. 15 plus 35, and I do that math and I get that it's 50. So let's look at the second problem. I have 2a plus 3 equals b, and then I have a plus b is 6. Well, if you will look, this b is isolated, and I know that this b equals 2a plus 3. So in the bottom equation, I'm going to replace b with the 2a plus 3, because that's what b equals. So I'm going to, and this time I don't have to use parentheses, because I have a plus sign and not a minus sign like I did over here. So I'm going to do my a plus b, which happens to be 2a plus 3 equals 6. And now I can combine like terms, so I get 3a plus 3 equals 6, and I can solve this for a. Subtract 3 from both sides. So you get 3a equals 3. Divide both sides by 3. And you get that a equals 1. Halfway done. Now I have to find b. So I'm going to plug this back into that top equation where b was isolated. So I end up with 2 times 1, because that's what a equals, plus 3 equals b. Well, that becomes 2 plus 3, so b equals 5. Now, this is not an x and a y, but I still need to write it as an ordered pair because it is still going to be a point where these two lines cross. My ordered pair, when your things are not x and y, just put them in alphabetical order, so a and then b. So my ordered pair is 1, 5. There is your solution to your system. Then down here, we're asked to find AB. Since there are no operation symbols, that means multiply. So I have to do A times B, which is 1 times 5, which equals 5. Let's look at a couple more. If you look at this next one, I have x equals 2y, and then I have 5x minus 10y equals 94. Well, I know that x is isolated, and it equals 2y. So in this equation, instead of x, I'm going to put 2y. So I'm going to do 5 times x, which is 2y, minus 10y equals 94. Well, 5 times 2y is 10y, so I end up with 10y minus 10y equals 94. Well, if I combine like terms here, 10y plus 10y, they cancel each other out. So I have 0 equals 94. Well, 0 does not equal 94. This is not a true statement. So what happens when you get to this point and you end up with stuff canceling and what you're left with doesn't make any sense, it doesn't equal each other, then what you have is a problem that has no solution. And if you'll remember from the other day, that means these two lines are parallel. They're going to have the same slope but different y-intercept. So these have no solution. Let's do this next one. Have x plus 2y equals 5 and then 3x plus 6y equals 15. If you will notice in this problem, you don't have a variable that is isolated. Neither one of these, I apologize, I want to move this. Neither one of these has a variable that is by itself. So the first thing I'm going to have to do is isolate one. Well, the only one that it is easy to isolate a variable on is going to be that top one, and this x is the only variable that's going to be really easy to get by itself because it has the number in front of it is 1. The coefficient of this x is 1, so it's very easy to get by itself. So I'm going to isolate this x by subtracting 2y from both sides. And when I do that, I get that x equals 5 minus 2y. Now I have x isolated. So I can now substitute 5 minus 2y in place of x in this bottom equation. So I'm going to do 3 times 5 minus 2y, because that's what x equals, plus 6y equals 15. I have all the same variable, which is my goal. So I'm going to distribute here. I end up with 15 minus 6y plus 6y equals 15. Well, let's put like terms together. Negative 6y plus 6y. Well, these cancel each other out. Oh, it's going to be like this one. But look, on this side, they didn't just they canceled out, but there was something else over there. This 15 is still over here on the left-hand side equals this 15 on the right-hand side. Now, instead of something not making sense like this did, this is a true statement. 15 certainly does equal 15 all day, every day. When this kind of situation happens, instead of having no solution, you end up with infinite solutions. And no, you cannot just draw the infinity symbol because the answer is not infinity. The answer is infinite solutions. Okay, so when variables cancel and what's left makes no sense, you have no solution. When variables cancel and what's left makes perfect sense, you have infinite solutions. So that means these are the same line. They are the exact same line, and so when I graph them, this one will graph right on top of this one. All right, let's do one more problem. Let's do a word problem just to make sure we're all good. So a jar contains nickels and dimes. There are 20 coins in the jar, and the total value of the coins is $1.40. How many nickels and how many dimes are in the jar? Let statements first. Well, the jar has nickels, and the jar has dimes. So there's my two variables. This is one of those problems where you have the total number of objects and then you have the value of the objects. Well, our total number of objects is 20 coins. That tells me that nickels plus dimes equals 20 coins total. My value is now where I have to include how much a nickel and a dime are. Please be careful here with your placement of your decimal. You could get this problem wrong, and people do it every time. Okay? We're going to do our nickels and our dimes, and the total is $1.40. So now the value of this nickel and dime matters. A nickel is worth 5 cents. Please make sure you write it as this. I don't know how many times this happens and somebody tells me that's the value of a nickel. This is 50 cents. This is 5 cents. Do not write this for the value of a nickel. A nickel is 5 cents, 0.5. So 5 cents is a nickel, 10 cents is a dime, and total I have to have $1.40. Now to solve this with substitution, because that's all we know at this point, I've got to have an isolated variable. I don't. I have an N and a D, and I have an N and a D, and they're combined on the same side on both of them. But I can easily isolate one of these. Switch colors here. I can easily isolate this N or this D because they have a coefficient of 1, and then I can substitute. I'm going to isolate the N. Get N by itself by subtracting D from both sides. So I end up, that's an ugly D, I end up with N equals 20 minus D. So in this equation, instead of N, I'm going to put 20 minus D. So I have 0.05 times 20 minus D plus 0.10D equals 1.40. I have all the same variable, distributive property first. And so 0.05 times 20, that equals 1, minus 0.05D, that's this part, plus 0.10D equals 1.40. Now like terms together, I have negative 0.05 plus 0.10. And I'm sure that that is 5 cents, but we're going to double check just to be sure. So I end up with 1 plus 0.05D equals 1.40. So I'm going to solve this for D. I want to get D by itself. So I'm going to start by subtracting 1 from both sides. So I have 0.05D equals, well, $1.40 minus a whole dollar is going to be 40 cents. And then I'm going to divide by 0.05. And I'm going to use my calculator because I don't want to have to keep track of all those silly decimals. You shouldn't either. And I end up with D equals 8. That tells me that there are 8 dimes in the jar. Now to figure out how many nickels are left in the jar, there's 2 ways you can do this, okay? Common sense should help you. You know there's 20 coins total. 20 minus 8 will give you the number of dimes. Or you can substitute it back in. I'm going to substitute it back in. I know that D equals 8, so I have N equals 20 minus 8. So nickels equals 12. Now in this kind of problem, because it is a real world problem, you do not have to write it as an ordered pair. You are just going to tell me there are 8 dimes and 12 nickels. You don't have to write this as an ordered pair because it's a real world situation. It's, you know, you're looking for real actual things and not just numbers. This is your answer. 8 dimes and 12 nickels. So that is substitution. I hope that you took really, really good notes. We will practice this tomorrow. I hope y'all enjoy the rest of your weekend.